Section 7.5 homework calc. I'm going to do 3 problems to help you out today. 2 of them are similar. The first one I'm going to ask you to sketch the graph and label the vertices for, and then they'll give you a system of inequalities. Second one will be very similar, sketch and graph, another system of inequalities. And then the third one, getting a story problem and being able to sketch and graph the inequalities. So looking at the first one, I recommend that if you have y in the inequality that you isolate it for y. So I'm going to rewrite these inequalities. This second and third one, those are fine, but that first one I would probably write it as y is greater than or equal to negative 2x squared plus 2, and that's what I'm going to do here. So here are my inequalities. Y is greater than or equal to negative 2x squared plus 2, and then since there's no y in the second inequality, that's fine to have x isolated. And the third one already has y isolated, so those are the inequalities that I want to graph. So I'm going to go ahead and give myself a graph here. And we're just sketching it by hand, so don't feel the need to have this look exact. And now, a lot of times I like doing this. It'll be helpful for what we do well, when we start to label the vertices, and it'll help us for what we do in section 6 as well. A lot of times I'll come back here and I will number these so that I know which one I'm referring to. So for example, let's say I did the third one. I'll just go backwards. The third one is a line, and it's either horizontal or vertical because it doesn't have x or y. Hopefully you remember that y is equal to a number means that you have a horizontal line. It's saying that y is less than or equal to 1, so that's this line right here. And then what I tend to do is I'll just put a little 3 here next to it so that when I look back at that line I can tell that it's that equation that I'm referring to. Probably not such a big deal for these, but when you get a bunch of linear equations that aren't horizontal or vertical, it's kind of nice to see them. Alright, the second one, x is less than or equal to 2. That is a vertical line at x equals 2. That would be here. And again, this is my second inequality or equation. In terms of the shading, y is less than, so I'd be shading below this line. And x is less than, so I'd be shading to the left. So far I'm shading all of this little region here. And then hopefully I can identify that that top one is a parabola. Because there's no x term in the middle, that means it's actually in vertex form. And this would be another way of writing it. It would be to say negative 2x minus 0 squared plus 2. So the vertex point is 0, 2. It's right here. I could easily factor that, take out the negative 2, and it would leave you with x squared minus 1, which factors, of course, into x plus 1, x minus 1. So I have an x-intercept at x plus 1 and x minus 1. So I've got the vertex point and I've got the two x-intercepts, so I can draw a very accurate graph here. Now these all have the equal to on it. That's how I know to make these solid and not dashed. And then according to this parabola, its y is greater than. So if you put your pen or pencil anywhere on that graph, greater than means go up. It's shading outside of the parabola. So what I am looking at shading here are these. Is basically I have 2 regions. It's these 2 regions. So in terms of drawing the sketch or the graph, that's what you're looking for. Now in terms of the vertices, you want to look at what is kind of defining the point that you're looking for. And so what you're going to want to do is find your vertices, which we're going to have one here, 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 and then I suppose we can go ahead and find this one. Everything else would be kind of unbounded. There's nothing kind of containing it. So I always say go look at vertical and horizontal lines because they are telling you what the x or y value is. So for example, here's a vertical line. That came from that equation. It's saying that x is equal to 2 on any point on that line. So I know for this one, x is 2. I know for this one, x is 2. Now I'll look at the horizontal lines and do the same thing. If I look at this horizontal line, I know that y is 1 for all of these. So there I've got the whole point. This point is something 1, and this point is something 1. Alright, realistically they probably are not going to be looking for that since that doesn't have a nice defined region. This one does, but we can go ahead and find it. Alright, now when you get to all the horizontal and vertical lines are taken care of, then you're going to end up using the other equation. So for example, let's say I want to find that point. Well, I know x is 2, I got that from using line number 2. What other line goes through it? Well, it's line number 1. So I just take the 2 for the x value and plug it in here. So I would get y is equal to, ignore the inequality at this point, it's negative 2 times 2 squared plus 2. And that's going to give me 4 times negative 2, so negative 8 plus 2, or y should eventually give me negative 6. So I know this point is 2, negative 6. I know that point is 2, 1. Now I'll come back to this one. Equation 3 said that the y value is 1. Plug that y value into equation 1 and solve for x. So 1 is equal to negative 2x squared plus 2. It's quadratic, so you're going to want to set it equal to 0 and solve. So 0 is equal to negative 2x squared plus 3. And because the b term is missing, I'm going to bring that work up here. Because the b term is missing, I can just get x by itself. So I can subtract 3, divide by negative 2 to get 3 over 2. And then, of course, I have to take the square root, and I'll take the square root separately of those fractions. Now, it's plus or minus, which is good news because that's going to give me both of these answers. And then remember to rationalize. So I'd have to multiply by the square root of 2 over square root of 2. Sorry that this is getting kind of congested here. That's going to give me the square root of 6 over 2. And that's what this would be, positive square root of 6 over 2. This one would be negative square root of 6 over 2. So now I've got the graph, which is probably the most important part of this for right now. And then I've got the vertices. The vertices really come into play for what we're doing tomorrow in 7.6. All right, on to the next one. Sketch the graph of and label the vertices. Okay, I normally would solve it for y, but because y is squared, I'm not going to. Hopefully we remember our conic sections and we recognize that those two things are both circles. So, I'm going to go ahead and give myself a graph here. And then as long as I remember that those are both circles, you might want to maybe refresh that in your memory, that when you have two squared terms being added together and the numbers in front of the squared terms are the same, it's a circle. If it's not, it could be an ellipse or a hyperbola. I'll just tell you right now that we won't see that. If anything, you're going to see a circle and that's it. You won't see any ellipse or hyperbola. But if it is a circle, and it is, this is the radius, not that specifically, but the square root of that. So for the first one, I have a circle with a radius of 3 centered at the origin. So if I start at the origin, there's my center. I go 1, 2, 3 to the right, 1, 2, 3 to the left, up 3, down 3, and I can draw my circle, solid line because of the equal to, and do the best you can to make a circle. If you're like me, it's going to probably look like an oval or who knows what. But there's my circle. Now in terms of the shading, because this is actually a connected, like the parabola up here wasn't connected, it was open, so I could do the up or down thing. I can't do that for something that's enclosed. For example, it says less than. If I did it here, that looks like I'm shading inside. What if I do it here, less than? Now it looks like I'm shading outside. So because the object is enclosed, I can't do that where I just say it's greater than or less than. Now you want to do kind of what you first learned to do when you were shading, do a test point. I suggest picking something that's not on the line. You have to pick something not on the line. I would say pick the center. It's an easy thing to plug in. If you put 0 in for x and 0 in for y, you're going to get 0 plus 0 is less than or equal to 9. Is that true? Sure it is. 0 is less than or equal to 9, which means you are shading toward the center. Basically, you are shading inside of that circle. All right. Going to the next one. The next circle is going to have a radius of 1. Solid line, there's that circle. It's greater than, again, plug in the center. It's 0, 0. 0 plus 0 is greater than or equal to 1. Is that true? No. So I'm shading away from the center. I'm shading that direction. And so I have something that looks kind of like a washer here. In terms of vertices, since these two things aren't intersecting, I would say that we just don't have any. Again, in the long run, the vertices aren't important for what we're doing right now. It's more for section 7.6. All right, on to the story problem. So now I've got to see, can I get this story problem set up correctly? So I need to be able to pull out the inequalities. And it's like what we did, in section, I think it was 7.2 or 7.3, where we had to read the story and then pull out the equations. Same thing, it's just inequalities. A store has two models. That's important because I know I have two models. I know I should have two equations, two variables. Because of the demand, I want to have at least twice as many units of model A as model B. That's going to be something I'm going to have an inequality for, so that's going to be important. The cost to the store for the two models are $800 and $1,200 respectively. Management does not want more than $20,000 in inventory at one time, and it wants at least 4 of model A and 2 of model B. That is going to be important for another equation. And then, of course, this is going to be important. So those are the 3 pieces of information that I want for my inequalities. So let's take a look at the first one that I have underlined. It says at least twice as many of model A as model B. So at least twice as many of model A. So think about what you have to do to that. If I have twice as many of A as I do B, would I say this, or would I do this? And think about that. At least would mean it would be greater than or equal to. Does this represent that A is twice as large as B, or does this represent that A is twice as large as B? Ignoring the inequality. This, if you just put a random number and let's say A is equal to 3, that means B is equal to 6. That means B is actually twice as large as A. I don't want that one. I want this one, and I have the inequality mixed up. It should be A is greater than or equal to 2B. And now if you kind of reread that, at least twice as many units of model A. If A is twice as large as B, I have to multiply B by 2 to kind of balance them out if you want to think of it that way. Alright, so that's the first inequality. Second one I'm going to take a look at is, let's take a look at this underlined information. I want to have at least 4 models of A. Well, that means A is greater than or equal to 4. And at least 2 of B. That means B is greater than or equal to 2. And now the only thing I haven't accounted for is I need to take a look at what I have circled up here. It says that I have $800 and $1,200 respectively. So $800 is referring to A, $1,200 referring to B, and I do not want more than $20,000. So if I have $800 tied up in A, $1,200 tied up in B, I do not want more than, so I want less than or equal to $20,000. And these would be the 4 inequalities that you are looking for. Alright, and now in terms of graphing them, what I would probably do, because A and B, I would probably switch these to X and Y. I would probably say, if I wrote that one down, I would say it's X is greater than or equal to 4. B is going to represent Y, so Y is greater than or equal to 2. Since I'm calling this X and this Y, I should try to solve it for Y. So maybe over here I'll do that. I've got 1,200 Y is less than or equal to negative 800 X plus 20,000. I see all the zeros here. I'm just going to get rid of 2 sets of zeros. In other words, divide everything by 100 just to make the numbers a little bit nicer. Divide by 12 and simplify. 8 divided by 12 is going to give me negative 2/3 X. 200 divided by 12, if you need to, you can go ahead and divide that out with your calculator or whatever. That's eventually going to give you 16.6 repeating. And I just want to have an idea of what that number is, what it's between. So Y is less than or equal to negative 2/3 X plus 16.6 repeating. Alright, and then of course I've got this one where I'm saying that X is greater than or equal to 2Y. Typically we would solve it for Y, so I might divide and say that Y is less than or equal to 1/2 X. And now I've got inequalities that I'm used to. Alright, so now let's go ahead and give myself a graph. Now you notice because of those two, I'm basically looking at just the first quadrant. So when I draw this graph, I don't need to get carried away drawing out a negative x-axis or a negative y-axis. The reason I want to know what that number is specifically is because I want to have an idea how many tick marks do I need to make here. So I'm going to make a few and then I'll figure out how to label this. I want to make sure I get to at least 17. I've got 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go by twos. So 2, 4, 6, 8, and so on. Said you just want to make sure that you cover that number. And whatever you do on the X or the Y-axis, I guess I would suggest doing it on the X-axis to keep them uniform. You don't have to do that, but it would probably be a good idea. All right, and now we'll go ahead and we'll start graphing our inequalities. So let's take a look at the first one. X is greater than or equal to 4. Remember, that's a vertical line, and that would be here. So there is my X is greater than, mean that direction, 4. And again, if you want to do the little thing where I label it with a 1, that's kind of nice. Don't have to. Second one, Y is greater than or equal to 2. Well, that's a horizontal line. Greater than would mean that direction. There's my second equation. Third one, y-intercept of somewhere between 16 and 17. So 17 is here, it's right around here. You notice I'm just putting it at 16 and a half. It'll be close enough. You want to try to be as accurate as you can, but in terms of that number, that'll be fine. My slope is negative 2/3. Now, even though I'm going by 2's, it doesn't matter. I just have to move tick marks. So go down. If you want to put little half tick marks in here to help you, you can. I'm going to go down 1, 2 tick marks. That takes care of the negative 2, and now 3 to the right. So remember, I'm going by tick marks, 1, 2, 3. And then you can kind of guesstimate here, it's right about there. And here is inequality number 3. And it says that it's less than, so I should be shading down. So as of right now, I'm shading that little triangle. And then the last one I have a y-intercept of 0. A slope of 2, so again I'm moving by tick marks. I'm going to go up 1, 2 tick marks to the right, and have something that looks like this. And I am shading down because it's less than or equal to. And what you end up shading is this little triangle. All right, like I said, that'll be important for what we end up doing in section 7.6, because eventually they will ask you to find these vertices. It's not asking us to do that in this problem, but that's what section 7.6 gets to. All right, I hope that helps you out with your homework. Let me know if you need any extra help.